Hello again, this is Mr. Wynn, and today's video is about properties of real numbers. Numbers may be classified by their type. Every number that you've seen or know is classified as a real number, which is R. Real numbers are then split up into rational, which is Q, and irrational, which is I. Rational numbers are any fraction or number that could be written as a fraction or decimal that ends or follows a repeat pattern. For example, 0.3 repeating is rational. Irrational is any never-ending decimal that is random. So it comes usually from square roots or special numbers like pi. They never end and you don't know what the next number is, or it's not a pattern. Also, numbers can be classified as natural, which is n, whole, which is w, or integer, which is z. Natural are basically positive whole numbers, but they don't count zero. Whole numbers are basically the positive whole numbers, including zero. Integers are positive and negative whole numbers, including zero. There are two notes. Make sure you simplify the problem first. Just because it has a square root doesn't mean it's automatically irrational. And then note 2 is numbers can have multiple types. So here's an organized chart with examples. You can pause it here, but I'm going to move on. Example 1. Classify the following numbers according to their set name. So set name is just what I said before, like real, rational, integer, whole, natural, that stuff. So first, I see the number negative 23. Well, it's a normal number, so it's always going to be real. So I always put R first. After that, negative 23. Well, remember, reals are sorted as irrational or rational, always. So you need one of those. Well, negative 23 doesn't go on forever. It actually stops. It's actually the fraction negative 23 over 1, or you can say negative 23.0. It ends. It terminates. So it's also rational, which is Q. And then it's a negative whole number, which makes it an integer, Z. So this has 3 classifications. You need all 3 of them. If you have 2 or just 1, you're going to get the problem wrong. All right, B. The square root of negative 50. If you've ever put in the square root of negative 50 in a calculator, you will see that it says 7.071067812, and it keeps on going forever and ever. It will never stop, and there's no set pattern. All right, so keep that in mind. But first, it still is a number. It's something we've seen. It's real. And now, is it irrational or rational? Rational means it ends. Irrational means it goes on forever, randomly. This is actually irrational. Once you get irrational, you stop. It doesn't go further than that. Irrational, I can only go with R. All right, C, negative 4 over 9. Well, it's still real. And all these are going to be real, by the way. And then now it's a fraction, negative fraction. But if it's a fraction, it's always rational. And then it's not a whole number, so you can't do N, you can't do W, you can't do Z. D, negative 185, real. It ends, it stops, so you make it over 1, or you can just put a 0.0. And it's a negative whole number, Z. Over here, I see a square root sign, like B, like in square root of 50, but that doesn't mean it's automatically irrational. You want to simplify it first. We know the square root of 49 is actually 7, so this is really negative 7. Well, when we do negative 7, we know that's real. We know that's a fraction or decimal that ends. And it's a negative whole number, so it's Z. So it's those 3 things. Square root 95, I put in the calculator, and I see that it does not simplify. 9.746794345, so on, random. So I can't reduce it. So we know it's real, and it doesn't end, so it's irrational. Negative 7/8, well, it's real. It's a fraction, it's negative, but that doesn't matter. So it's rational, and it's not a whole number, so I can't use Z, N, or W. The last one, 0. 0 is real. 0 ends, it's rational. It is a negative or positive whole number, so it includes the integers. And it's also whole, because whole is 0, the positive integers, positive number, whole numbers, and 0. This is not a natural number though, so do not put n. So 0 has 4 of them. On top of that, we have properties or rules that you must be able to identify. You have to memorize this. There's no way around it. So the first one is, well, all these work for addition and multiplication. There's 2 parts. So there will be a commutative property for addition. And I'll explain this. Commutative is like when you commute somewhere. That means you drive around, you move somewhere. So we're moving spots, we're switching places. If I have a number 3 plus 5, I can switch that to make 5 go first and 3 second. I still get 8 equals 8. It's still true. So that's the commutative addition property. Multiplication, same thing. I could say, hey, I can want 2 times 3. No, let's switch that around. Let's do 3 times 2. Both of them equal 6. The associative property is where you don't move. You just change groups. So as you notice, the parentheses switch from around A and B to around B plus C, but none of the letters moved. For multiplication, same thing. A times B grouped together then times C is the same thing as A times a group of B times C. So if you try it in your calculator, if you do, what, 3 times 4 times 8, that's the same thing as 3 times 4 times 8. You will get 96 on both sides. Identity. Your identity does not change. Identity means what do you do, either addition or multiplication, that keeps you the same. So for addition, what do you add to yourself to stay you? Well, you add 0. Anything plus 0 is the same thing. For multiplication, what do you multiply by to stay the same? Well, you multiply by 0, you change 0. So you multiply by 1. So anything times 1 is the same thing. Inverse. I'll talk about it next slide, but basically, what do you do to yourself to get 0? Or what do you multiply yourself by to get 1? Closure just means the set. If you do A plus B, it's still real. If you do A times B, it's still real. And distribution, y'all know that. You gotta distribute A into both of these. You'll get AB plus AC. Same for the backwards. So let's try this. Just name the property illustrated by these. Well, for A, I start with this, I end with this. What happened? I just distributed. So this is the distributive property. All right, 10 plus 0 becomes 10. What happened from here to here? I added 0. Nothing happened. I'm still the same. This is the identity. Identity property of addition. You put a plus sign right there. Distributive doesn't have addition and multiplication. It's together because in distribution you see both the plus sign and the multiplication sign. All right, 2 times 3 paired together, then times 4 becomes 2 times 3 times 4 together. Well, what happened? From here to here, I noticed the parentheses, the parentheses or the brackets, remember, same thing, moved. First it was around 2 and 3, now it's around 3 and 4. And we're also multiplying. So this is the associative property. Associative property of multiplication. All right, the next one, 19 plus 2 is what I start with. I end with 2 plus 19. What happened? They switched spots. That would be the commutative property. Commutative property of addition. The last one, 9 plus negative 9 becomes 0. This, you'll see on the next slide as well, is undoing stuff, getting to 0. That's called the additive inverse. Inverse property. All right, make over this a little bit. All right, example 3. I just gave y'all some brief overview. The additive inverse gets a number to add to 0. This is usually just the same number but multiplied by negative 1. So when I say additive inverse, I'm expecting 3 plus some number x to get me to 0. Well, if you do algebra, you subtract 3 from both sides. X equals -3. So I know 3 and -3 are inverses, additive inverse. 3 plus -3 equals 0. Same thing for this next one. If I have -5 plus something equals 0. If you add 5 to both sides, you get x equals 5. So those are inverses. Just notice the sign flipped from +3 to -3, -5 to +5. This next one, C, it goes from 10 to -10, because 10 plus -10 equals 0. The multiplicative inverse gets a number to multiply to 1. The multiplicative inverse gets a number to multiply to 1. This is usually just the same number as a fraction, but you flip it. You keep the sign. So, find the multiplicative inverse of each of those same numbers. Well, 3 times some number, I'll say x, equals 1. If you do algebra, you know you divide both sides by 3. And you get x equals 1/3. So 3 and 1/3 are multiplicative inverses. For B, I have -5. Well, -5 times some number x equals 1. Algebra says divide both sides by -5. You get x equals -1/5. So I know -5 and -1/5 are multiplicative inverses. And for C, I'll just do the trick. We know 10 is basically 10 over 1. I just flipped that. So now it's going to be 1 over 10, because 10 times 1/10 equals 1. Alright, I'll leave you with this practice problem. Find the additive and multiplicative inverses of this number. They're the answers. If you answer those, you should be fine. Thanks for watching. I'll see you in class.